This is Foundations of Math in Pre-Calculus 10, Chapter 3.3. We're looking at solving more right triangles. Again, we want to draw the diagrams and label the sides and angles so we know which trig ratio to use. And for this section, the goal is to solve all sides and all angles. Use complementary angle property to speed up finding solutions. That is, angle C equals 90 degrees. So, angle A plus angle B equals 90 degrees. So, angle A equals 90 degrees minus angle B. Or the other way around. Angle B equals 90 degrees minus angle A. And you should note that other angle measuring devices are called transit, alidade, theodolite, and sextant. Okay, so complementary angle is easy to solve. This is 90 minus 25, that's 65 degrees. The next thing, we label the sides. The labels help us figure out which side is which at the end. So from the 25 degrees, we have hypotenuse and opposite, so we're using sine. Sine 25 equals x over 100. X equals 100 sine 25. So x is approximately 42.3. Again, no units, so we don't need units here. Looking at this side, we're doing adjacent and hypotenuse, so that's cosine. 25 degrees equals y over 100. Optionally, we could use the 65 degrees and say sine 65 degrees equals y over 100. But we'll stick with this. So y equals 100 cos 25 degrees, and we get approximately 90.6. Let's look at this triangle. To solve for everything, we need to solve for the angle first. 40 degrees, 90 minus 50 is 40. We'll label this side x, we'll label this side y. With the 50 degrees, this is adjacent, this is opposite, so we have tan 50 equals opposite over adjacent. So x equals 8 tan 50, and that's approximately 9.5. And on our calculator, 8 tan 50, 9.5. Now we can solve for y. We have adjacent over hypotenuse. That's cosine. Cosine 50 equals 8 over y. So y equals 8 over cos 50 degrees. And that is approximately 12.4. And this triangle is completely solved. Okay, so here's all our given values. We need to label our unknowns, x and y. This one says find AB, and the only way we get AB is by finding x and y and then adding them together. So x plus y. Okay, so we can figure out x, this is opposite over adjacent. So tan 51 equals x over 8. So x equals 8 tan 51. And x is approximately 9.88 meters. Okay, this one has units. So let's do this. 8 tan 51, 9.88. Okay, if we're solving for y, it's a similar setup. So tan 32 equals y over 8. Y equals 8 tan 32. That means y is approximately 4.999. So we'll just call it 5.00 meters. Okay, so length AB equals x plus y equals 9.88 plus 5.00 equals 14.88 meters. Okay, next problem. So there's different ways to solve this. This is the first thing I'm going to say. So you can use the different trig functions, and I'm going to show you just one way. So this is a slightly harder problem, maybe level 5, maybe level 6. We should label all the unknown sides. So A, this one's known, B, C, D, E, and F. So I'm roughly going to solve it in this order because we're given this side first, so we want to work our way across. Okay, we have 63 degrees, we have opposite and adjacent. Tan 63 equals 8 over A equals 8 over tan 63. And that gives us roughly 4.07. We're given centimeters here, so we need to write units down. Mark that so we don't forget it. Next, we can solve for B. And we have opposite over hypotenuse. Sine 63 equals 8 over B. B equals 8 divided by sine 63. And that's approximately 8.98. We can solve for the angles here. Angles 27, 90 minus 63. We can solve for this angle here. This is 90 minus 38, so that's 52 degrees. And this one is 90 minus 72, so this is 18 degrees. Okay, underline this answer. C. We know this. This is 8.98. This is 4.07. So C, we have 38. We have adjacent over hypotenuse. So this is cosine 38 degrees equals adjacent 8.98 over the hypotenuse. So C equals 8.98 divided by cos 38. And this gives us a rough answer of 8.98 divided by cos 38. 11.40. Now we can calculate D. We use the earliest number, b. So this is a tangent ratio. Tangent 38 degrees equals d over 8.98. So d is approximately 8.98 times tan 38. 7.02 centimeters. .02. Next, let's move on to E. We have 72 degrees, we have adjacent, we have opposite, so tangent again. Tangent 72 equals 7.02 over E. E equals 7.02 divided by tan 72. So E is approximately 2.28 centimeters. Looking at the last one, we have F. Again, we want to use the earliest one, that's 7.02. So we have opposite over hypotenuse, this is sine. Sine 72 equals 7.02 over F. F equals 7.02 divided by sine 72. And that gives us approximately 7.38. So A is approximately 4.1. B is approximately 9.0. C is approximately 11.4. D is approximately 7.0. E is approximately 2.3. F is approximately 7.4. And we drew all the angles on the diagram. Let's look at the last problem. It's the hardest problem. An architect wants to build a roof with angles of elevation of 30 degrees and 50 degrees, such that they meet at the peak. The total width is 20 meters. Determine the measurements for the roof's truss. Okay, it looks roughly like this, not to scale. We know this is 50. We know this is 30. This means we can solve for the angles up here. This is 60 in case we need it. 40 degrees. We'll call this A. We'll call this B. We'll call this X. We'll call this Y. And since we know the whole thing is 20 meters, this must be 20 minus Y. Okay, everything's labeled. We can start working. First calculation. We don't have a whole lot of numbers, so we'll just have to use variables. So with this triangle, tan 30 equals X over 20 minus Y. Let's rewrite this. X equals 20 minus Y, tan 30. Let's look at this triangle. Tan 50 equals X over Y. X equals Y tan 50. Okay, we have an X and an X, so we can use substitution. just like in our systems of linear equations. Substitute. So 20 minus y tan 30 equals y tan 50. Clean that up. Let's substitute the values. Tan 30, 20 minus y times 0.577 equals 1.192. So we expand this, get 11.54 minus 0.577y equals 1.192y, 11.54 equals this plus this, 1.769. Okay, divide both sides by this, and we got 6.523. And this is in meters. Okay, now we can calculate these two lengths. Z equals 20 minus y equals 20 minus 6.52 equals 13.48 meters. So x, we already have a formula for x. We can use either one. I'd use the shorter one. X equals 6.52 tan 50. And that's approximately 7.77. And we have two more lengths to figure out, A and B. So A, we can just use hypotenuse. Again, we want to try to use as close to the original number as possible. So sine 30 degrees x over A. A equals 7.77 divided by sine 30. So this is 15.54. Verify this on the calculator. Okay, that's good. And last one, B. Okay, we have this value and this value. This time we'll use cosine 50 degrees. So we're looking at Ka, y over b. So b equals y 6.52 divided by cos 50. And we get 10.14 meters. And this should say approximate. This should say approximate. This should say approximate, and this should say approximate. And this would be a level 7 or 8 question. And that completes this lesson.